So, our next group. Are we doing an intro round of applause? What are we doing here, team? Kind of. Okay. Lower the camera. That's cool.
All right. Minerals by Trousdale and Ramsey move on. All right. What is a mineral? A mineral is a solid chemical compound, and the defining factors include has to be organically occurring, a solid, it has to have a set chemical composition, and it has to have an ordered atomic arrangement. Minerals are organically created because they aren't created by humans. They're solid because they have to have a set shape. This means that it can't be a liquid or a gas. A good example of this would be like how water isn't a mineral, but ice is. They all have to have a set chemical composition, it's just the makeup of it. And finally, they all have to have an ordered atomic arrangement. This means that they have to grow as crystals, and also means that there needs to be some type of way for the elements to move for them to be able to form.
Okay. So rocks. So there are three different types of main rocks: igneous, sedimentary, and metamorphic. So igneous rocks are rocks that are formed from magma or lava, and magma is the name for lava that flows underground in the ocean, and lava is what flows above land. There are two different types of igneous rocks: igneous intrusive and igneous extrusive. Igneous intrusive is a rock that forms when magma gets slowly cooled underwater, and igneous extrusive means that it cools quickly above ground. Mafic and felsic describe the color and amount of silica inside of a rock. Mafic rocks have less silica, meaning they're darker, and felsic rocks have more silica, meaning that it's lighter in color. Sedimentary rocks are formed from an organic organism or deposition of minerals. Metamorphic rocks are rocks that undergo lots of pressure or heat and get their chemical composition to change, as well as their shape and color at times. Okay. So chemical composition. So minerals are formed from magma, which is why they're often seen in igneous and metamorphic rocks. However, this process can take up to millions of years, and minerals are usually formed in these environments: volcanic gases, sediment formation, oxidation, crystallization from magma, or deposition from saline fluid. And saline is just a fancy word for salt water. And the atomic structure of a mineral is what causes it to grow with a certain crystal structure, a specific pattern, arrangement, or alignment of atoms. And the atomic structure helps determine a mineral's microstructure, micro meaning small and structure meaning how something is built. So minerals form in magma because magma is a form of liquid, so the elements can move around. And metamorphic rocks because it gets heated enough in order for the elements to move around, because elements move around and that's how minerals are made. So, and sedimentary rocks because of geode, tuff, stalactites, and stalagmites as well.
All right, magma chambers. Magma chambers are where igneous intrusive rocks are made, and this is right above the mantle in the crust. And there's a diagram right here, and this is moving up to the surface. And then, so in these chambers, the magma is slowly cooling over time, which creates intrusive rocks. As they're forced up to the mantle, the walls are slowly being melted, and minerals are being collected. Olivine is one of those minerals that's collected, and it's like one of the first minerals to crystallize. You can see it in the diagram in B. And when it forms early, which is like, these are all mafic minerals, when they form, they slowly drift down to the bottom. And this causes the bottom to fill with mafic mineral crystals. And the felsic magma, which is less dense, is sent to the surface, which is because it's less dense. And that's why it has more amounts of silica. And that's why intrusive rocks have larger crystals. All right, mineral cleavage. So all minerals have a certain type of cleavage, and this is measured by the mineral structure and how it breaks. The mineral cleavage affects the shape of the crystals, the way the crystals grow, and how uh, difficult it is to break. So one plane cleavage is the top one. An example of that would be mica, and you can see it's like in sheets. The other one is felspar, which is two plane cleavage or two direction. And you can see how like two sides of it are smooth and the other one is rough. And feldspar is a mineral, and that I'll talk about later. And then three plane cleavage is howlite, or like that's an example of it. And it forms in cubes. And howlite's just another name for salt. And then no cleavage means would mean that it breaks in random ways. All right, so I decided to look at granite because it's very easy to see the different minerals in it. But granite's an intrusive mafic rock, and the minerals in it are felspar, quartz, hornblende, mica, biodite, and other common ones. And you can see the different parts of the minerals. There's felspar right there. It's orange. It's pink and white. And then there's quartz, which is like glassy. All right, felspar. Felspar is in all types of the rock, all rocks in the rock cycle. And it is, it makes up about 60% of the Earth's crust. It has perfect two-plane cleavage. And it can be weathered down to produce sediments. It's used a lot when making glass and some ceramics, and the chemical composition is at the bottom, and it's A is for potassium, sodium, calcium, T is for silicon and aluminum, and O is for oxygen. Quartz. Quartz is in igneous rocks like granite and other mafic rocks, and it's in sedimentary rocks like sandstone and shale, which can all be found in the Murray Headlands. It's common in rocks like schist, gneiss, quartzite, and other metamorphic rocks. It forms in igneous rocks when it cools slowly in geothermal beds. It's the mineral with the highest amount of silica, and it has no cleavage, which is why it's really easy to carve out of in the bottom. You can see because it doesn't break in a certain way. All right, mica. Mica is another mineral that can be found in gneiss, schist, and granite. It has one plane of cleavage, and it's perfect cleavage, and it occurs in igneous rock. The sheets that it forms are called sheet silicates, and it's heat resistant and doesn't conduct electricity.
Okay. So some of you may or may not have known this, but gold is a mineral. And the reason why it's valuable is because it's a hard mineral and it's pretty rare to find. There's also corrosion resistance and it's rust resistance as well, which is why it gets sent out in space and used for other causes that involves a mineral not having to rust. And it's embedded in quartz and other minerals, and the chemical composition is cubic. And we made a little prototype of what it might look like, but it wasn't in complete detail. But that is basically the atomic structure of how gold would look like. And it forms usually in magma. So when magma melts, the solid rock wall is underwater, carrying gold. The gold then mixes in with the other minerals inside of the magma. And when the magma cools, the gold is then seen in different rocks. Is especially seen in dikes because when the rock was underground, magma was spewed inside of it. And in that magma lays gold. So when you see a dike on an intrusive rock, it could be because of that magma or because of erosion. And the Sierras, not too far from San Francisco, have some volcanic interaction. And because that magma may contain gold, when it gets eroded down to the hillside, that gold goes down into the river, which is why there is a massive gold rush. And gold is also very dense, which is why it sinks all the way down to the bottom of the river. So, and the 7 different types of crystal structures are tetragonal, hexagonal, orthorhombic, monoclinic, and triclinic. And you can see in the diagram, you can see the veins in the magma underground. And when the magma spews inside those veins and then cools, you can then see gold, which is why people go like, gold mining and do other things like that just to find it. All right, so this is lizardite and serpentine, and lizardite is a mineral. And so what is lizardite? Lizardite is a mineral that you can commonly see in serpentine, and serpentine is a rock. And lizardite has a scaly texture and also has a perfect cleavage. Serpentine is also a metamorphic rock, meaning that the rock changes from immense heat or pressure. And lizardite originally comes from olivine, which Travis talked about earlier. And with the right conditions, olivine turns into the mineral lizardite. The reason why we thought lizardite would be an important mineral is because I believe it's California state rock and is rarely found. So we are pretty lucky to see it in San Francisco. So yeah, it also has one plane cleavage as well.
All right, and then here are sources for the for all of our research. Yeah. And then, does anyone have any questions? All right.
Second clap.